All right. Well, happy Monday, happy week 6, and I look forward to meeting with you for your group projects and your, I guess, proposal meetings. And I just kind of want to put this disclaimer out there. Okay, I'm gonna I'm not trying to be mean during the proposal meetings, but I do try to be thorough when I ask questions, and I do want to make sure that students do understand the data. They understand kind of that they have an appropriate data, they have an appropriate scope for their project, and so I'll be asking a lot of questions. It's okay if your answer to the questions is I don't know, or we'll look into that, or we'll figure it out. And it's also okay if after the meeting, if your confidence in your data is shaken a little bit, if you want to kind of change your data and things like that, that's also okay. Ideally, we're always hoping that the data that you've picked out is going to work out great and things like that. That of course that's what we want. But sometimes, and I ask you to send me your data 24 hours in advance, so I can kind of take a look at it and just kind of poke around and just, I don't spend too much time on each data set, but sometimes I'll notice some problems or some issues, or I'll have some questions about things, and I'll come, during your proposal meeting, I'll ask you some questions there. And so anyway, all of this is all for the hope that our final project is a good learning experience for everyone. It's very open-ended. There's a lot that you can explore. There's a lot of things that you can do. I don't necessarily personally hold your hand, but again, use me as a resource. Okay, come to office hours if there's something. If you have an idea and you feel like, okay, I think this is a question that we can answer with the data, but I'm struggling writing the code. I'm not quite sure how to go about this. Come to office hours, and I'll try to help your group out and figure out how to do it. And if you're also, if you started in one direction and things aren't quite panning out the way you want them to, also, come to office hours, and I can kind of, you can bounce ideas off of me, and I can also make suggestions. Okay, so that's the hope. What we're going to do is I'm going to start kind of transitioning. These lectures will be a little bit more demonstrations. I'll add some commentary. I'll do some explaining and introduce some kind of concepts and ideas as we kind of look at different data sets. And so I'm asking for volunteers for their data, some groups, and I think it's only upside if your group volunteers data. We can use it in kind of a class discussion, and I guess I would expect the group to come, and we'll take a look. But today I picked out this data set. This data set is looks at hotel reviews from the website TripAdvisor. So if you're not familiar, TripAdvisor is just kind of a place where people can leave reviews on different attractions, different things. Like if you're going to go on vacation, you can leave reviews for a hotel and things, or a park, or whatever it is. Okay, and Las Vegas is a very popular destination with lots of hotels along in Las Vegas and along the Strip. And so there was I guess a research article from there's a journal for tourism management perspectives. This is an academic journal. And they did some data mining. They collected a whole bunch of reviews from the TripAdvisor website back in 2015, and we're going to go ahead and take a look at the data. So if you're following along, make sure you've downloaded both the CSV file for the TripAdvisor reviews, and then the kind of the demo RMD file that we're working through today. Okay, so the first thing I'm going to do is I'm going to go ahead and load up the tidyverse, okay, and then I will load in the CSV file. All right, and so I have 504 reviews, 20 variables, or I'm sorry, 504 observations, 20 variables, and I hope that has worked for you. And then I'm just going to go ahead. Anytime you load, read in a CSV file, one thing I always recommend is you click and just kind of make sure it looks correct, right? So, one thing is you can always kind of double click your CSV file and open it up in Excel and see what it looks like. All right, and so this is kind of what it looks like in Excel, and then and you can kind of compare it to what it looks like in R, and you want to see things match up. And so the first couple reviews, user country USA, number of reviews 11, number of hotel reviews 4, helpful votes 13, score 5, period of stay December through February, traveler type friends, and so that looks good. And this is information about, I guess what they did was if you go on the TripAdvisor website. So I strongly recommend this. If your group is working with data that was scraped from a website, okay? So there's a lot of kind of data being scraped from websites and things like that. Verify the data by going to the website and seeing if you can come across some of the same information. Now, I don't know if I'll find any of these exact information, things, but we'll look at Las Vegas hotels in at TripAdvisor, and then so here is. Oh, now it's trying to expect me to go, but okay, let's just go ahead and we'll click on. Wait, I want to read some reviews. Okay, the Venetian Resort. How do I read some of these reviews? Okay, all right. The Venetian Resort. Okay, so here the Venetian is okay. So overall has an average of 4.5, has 33,643 reviews. It's a 5-star hotel style romantic family resort, has these features and whatnot. And here is someone's review. Someone left a review in May of 2023, a 3-point rating, and with a comment, be prepared to pay extra for everything. And meanwhile, here's a person who left a 5-point review, whatnot. Okay, so all right, that's fine. And if you click this person, okay, or actually underneath this this person's thing, there's a little thing. It says 60 contributions, 65 helpful votes, and I guess you can click the user profile and look at some of the reviews that this person left. Okay, but anyway, that's what we have, and some of that information is held here. So I guess number of reviews is kind of like number of contributions. Number of hotel reviews, I don't know where that information comes from, but something helpful reviews, helpful votes, the score, which is how many points they gave to that thing, and then also information about their thing. Okay, and so that we got reviews from the Circus Hotel and Casino Las Vegas, which is a 3-star hotel, has 3,773 rooms. The user came from North America, or we have users from Europe, and then I guess also information about how many years this person has been a member or something on TripAdvisor. Okay, one thing I like to do, and you don't have to do this, but I think this will make your life easier, is if you rename columns in your data set, especially if your names don't follow kind of our rules for naming things, which is basically like if your data set has spaces, anytime you want to refer to a column that has a space in it, you have to like start it off with a back tick, and it's just a tiny bit annoying. So, if you click names on your data set, names Las Vegas, this is what we have. We have user space country and number dot space reviews and whatnot. And there's a library called Janitor, and if you don't have it installed on your computer, you might have to go over to the packages section, and you might have to click install, and you'd install Janitor. Okay, right, so you just type in Janitor, and then you would install that. If you don't have it installed already, you can call in library Janitor. And then what I'm going to do is I'm going to pipe our data set Las Vegas into clean_names, and I'm going to save that back into Las Vegas. And after I do that, then names Las Vegas gets fixed up, and we can see, user country is still user country, but the space has been replaced with an underscore. Number of reviews is replaced with NR_reviews. It gets rid of the dot. Number of hotel reviews, helpful votes. So basically all of these things have been renamed, all lowercase, and this just makes it easier for us to kind of work with the names in a data set. So I recommend that. Again, you don't have to do it, but I do think it makes our life easier. Okay, is so far our code running okay? Encountering any problems here? Okay. What we're going to do is let's just kind of take a look at average customer score for each hotel. So I wrote the code here, but hopefully you can start to think of how to go about writing this code yourself. And so here I wanted to just say, okay, what's like the average score for, the Bellagio Hotel, or what's the average score for, the Venetian or the Wynn Las Vegas. So I'm going to take our data set, and what we're going to do is we're going to group by the hotel name. Okay, we're going to group by the hotel name, and then I'm going to calculate the mean score for this thing. All right, so I'm going to do group by hotel name, and then we pipe that into summarize, and then we're going to say, all right, calculate a new column. We're going to do average_score, and we're going to do mean score. So score is kind of the score that the customer left. So 5 stars or 5 points or 3 points or whatever it is. And then we'll count how many reviews, and then and we'll arrange them by descending order of score. So the highest scored hotel goes top, and then we'll go ahead and print all of our data. I think there's 21 hotels represented. Okay. So I think if I do 21 times 24, that's our 504 reviews. So the authors of the paper did something, a little bit odd, and so I'm not 100% sure if I agree with their methodology, but what they decided to do is they were going to just download 24 randomly or arbitrarily selected reviews. I think randomly selected reviews from the hotel, which is a little bit strange because, if you look at the Venetian Hotel, there's like 33,000 reviews, and they're just selecting a random selection of 24. And they said they're going to do 2 reviews from each month. So 2 from January, 2 from February, 2 from... So that was what the authors of the paper decided to do, and that's what they put into this data set. I don't know if that was a great technique or not. It seems like there's a lot of kind of room for stuff to, there's kind of a lot of kind of random noise and stuff. So, but anyway, that's just what we have in our data. So again, if I were to run a scraping program that did this, I would probably collect more than just 2 reviews per month, but that's what the authors decided to do. Okay, and so with our 24 reviews, these are kind of our top rated hotels in 2015, and so I don't know if things have changed, and and so these are the Circus Hotel has kind of the lowest average score of 3.2, and we have these things, and they keep building new hotels in Las Vegas. I don't know if you guys ever go to Las Vegas, but they are constantly building new hotels and things like that. Okay, one thing I wanted to that I thought was kind of interesting was I wanted to see, hey, is there a difference in kind of the scores that the hotels get based on their star groups? Okay, and so if you're not familiar, a hotel star rating is unrelated to the scores that a hotel gets. Okay, so you have like 3-star hotels, 4-star hotels, and 5-star hotels, but those star ratings aren't necessarily an indication of how nice somebody's stay or their opinion of the hotel is. The star rating is simply like how many luxuries and amenities does the hotel offer. I don't know what the exact standard is, but usually a 3-star hotel will have a restaurant on the premises of the hotel. Okay, whereas a 2-star hotel will not. So like if you go and you stay at, if you go to like Disneyland or something, it's like surrounded by hotels, right? Some of those hotels will just be like, you go in, you check in, and you have a bed, and there's probably a TV in the room, and that's about it. Okay, and it could be a 1 or 2-star rating depending on, I don't know if they have like a pool or not. Okay, I think like a 2-star will probably have a pool, 1-star will not. If there's a restaurant on the grounds of the hotel, that you don't have to actually leave the hotel and walk across the street or something. If you have if a restaurant is part of the hotel, then it might be a 3-star hotel. And then, a 4-star hotel will have additional amenities like they might have like a fitness room or laundry on the premises. Like they'll offer to do laundry, like it's like really expensive and things like that. And then a 5-star hotel will probably have like a spa where you can get like massages and things like that. And basically it's just like how many like of these additional amenities can you get? And, obviously you generally have to pay more money for the higher star hotel. And there, it's a double-edged sword. When you pay more money for something, you kind of expect more from it. And so a customer can go to a 5-star hotel and leave like a 1-point review, right? So I want to use the word point for like the score that they give the hotel, right? Whereas, a customer who goes to, say, a 3-star hotel, wasn't expecting a ton, but, they said, hey, this place was nice and clean and all of that. They can give it, 5 points in their review. So the number of points the hotel gets is not necessarily related to the number of stars. But I just had kind of this question, like, if we look at all the 3-star hotels, if we look at all the 4-star hotels, if we look at all the 5-star hotels, is there a difference in the point ratings? Okay, so here I'm taking our data, and this time instead of grouping by the hotel name, we're going to group by hotel stars. Okay, and then we will calculate the mean score, which is the point rating, and we'll also look at the standard deviation of the score, and just also see how many reviews were left for kind of these different hotel star ratings. Okay, and so we have 3-star hotels, 4-star hotels, and 5-star hotels. And what we see is that the average rating for a 3-star hotel is 4.02 points. For the 4-star hotel, the average rating is 3.88. And for the 5-star hotel, our average rating is 4.38. Okay, so that's what we have. And we might say, okay, you know what? Let's create a plot. Let's just plot all of the reviews, based on the different kind of hotel stars that we get. Okay, so here I did ggplot, and I'm going to put hotel stars across the x-axis. So across the x-axis, I'm going to see a location for 3, location for 4, and a location for 5. And then for the y-axis, we're going to put the score, which is the number of points the customer gave to the hotel, which I think is on a point scale from 1 to 5. 1 for terrible, 5 for great. And we'll do geom underscore point. Okay. Oh, I guess before I forget, let me give you some view quiz answers. I'll go ahead and give you your first two, which will be the letters C and B. C as in cat, B as in bear. C as in cat, B as in bear for our first two view quiz ratings. Okay. All right. Is this the workbook and the code kind of working for you guys? Okay. So this is what our plot looks like, and what can we say? What happened here? Is this what it looks like for you? It's just like 5 dots, right? So this is a terrible graphic, okay? Like if you put this in your final report, you know, I will dock off lots of points, right? This graphic is worthless. There's nothing of value conveyed here, okay? All this is saying is that, yep, there was a 3-star hotel and somebody gave it 1 point. And then there 3-star hotel and somebody gave it 2 points, and 3-star hotel and somebody gave it 3 points, okay? And the problem is that there could be like 50 people who gave 5-star or 5-point reviews, and 50 people, but they all just get plotted on top of each other at 3, 5, at the coordinate 3, 5, right? Because all of these people, okay, so they left reviews for Circus Hotel and Casino, which is a 3-star hotel, okay? This person who gave it a score of 5 gets a point at the same place as this person who gave it a score of 5. And all of these people who gave it 4 points, their dots all just get plotted right on top of each other, okay? And so if you have this issue where everything just gets plotted on top of each other, you can't really gain any information. We have no idea how many dots were there, right? So this plot is completely worthless to us. So one thing we can do is, rather than have the dots plotted right on top of each other, we can do something called, we can jitter the dots, okay? And so here I picked some values, and I say, hey, let's jitter the width 0.2, let's jitter the height 0.05, but you can play around and see what happens as you select different values for the jitter. I also chose alpha 0.2. Alpha brings in a little bit of transparency here, okay? So when I do this, okay, the width, I'm jittering 0.2, so it goes from, the width goes from, say, 2.8 to 3.2, and, 3.8 to 4.2, and 4.8 to 5.2, and it jitters them kind of horizontally, and vertically it jitters them, 0.05. If I say jitter, 1, okay, then it just kind of scatters them. And this makes it really hard to tell what these things are, right? So some of these dots are like remember, you can only leave 4 points or 5 points or 3 points for the thing. And this kind of makes it look like there's a continuum of points, which is not really the case, okay? So here, you can do 0.1, and this kind of indicates like, okay, these are all the people who gave it 4-point reviews. These are all the people who gave it 5-point reviews, and so on and so forth. There's 3 people who gave it 1-point reviews, 3 people who gave it 1-point reviews here, and 1, 2, 3, 4, 5, 5 people who gave these 5-star hotels, 1-point reviews. So they were, they paid a lot of money to stay in the 5-star, get a 5-star experience, but they were disappointed, so they left a 1-point review, which, I understand, right? Like if you paid a lot of money for a nice experience and like something goes wrong, I mean, you don't know, right? There's like, we have names for people who complain to the manager about everything, and we can imagine, some of the reviews left behind are probably people who complained that I don't know, the water pressure on the hot hot side of their faucet was just a tiny bit weaker than the what, I don't know, right? People can complain about whatever. I mean, maybe it's a big issue. But this gives you a little bit more sense of like, okay, certain areas, like there were quite a few people who left 5-star or 5-point reviews for the 5-star hotels, right? But there were also quite a few people who were, quite happy with this, right? So, play around with this, with the width, you can also mess around and see if you change the width for the hotel stars. Now it seems, now it's, again, hard to kind of tell. This, you change how much jitter you have. And so go about testing that out. Okay, another option is there is geom_count. Okay, and what geom count does is it takes basically this plot where you get one dot at 3,1, 3,2, 3,3, but it scales up the size of the dot depending on how many values are at that location. So we can see 3-point reviews at 3-star hotels is this many, and we can see there's for the 5-point hotels at the 5-star hotels there's quite a few. That dot is much bigger than say the other dots. I don't know. I think I don't know. You can. There's probably other things you can mess around with, but these are some options that you can use as far as representing how many are at these different coordinates. I think my preference is for the jitter. I don't know how you feel. I'm going to add one more, and I'm going to just kind of copy this. One thing for if you have so these are issues where your numeric output is like discrete, okay, where you can do like 1 point, 2 points, 3 points, 4 points, or 5 points. Versus if you have a continuous thing, box plots are great, but you're going to see, if I do a box plot here, for a box plot, I need to do AES group equals hotel stars. Okay, so for the box plot, we do ggplot x equals hotel stars, y equals score, and then for the box plot, we want to group it, create groups based on hotel stars, and we get these kind of these 3 box plots, and unfortunately, it makes the like the box plot for 3-star and 4-star hotels look identical. Okay, and that's remember with the box plot, it plots Q1, the median, and Q3. And again, because you have such distinct values, the values are discrete. You either leave 3-point reviews, 4-point reviews, or 5-point reviews. You don't have much distinction between these things. So in this case, I would say the box plot, again, is not going to be a useful thing, right? So creating a box plot is not useful for this data because the reviews are, the points for reviews are discrete. So again, as you create your graphics, as you do these things, always ask yourself, hey, is this doing something useful? Okay, so when we looked at the average star rating, if I kind of go back, and we said the average, not average star rating, average score for a 3-star hotel is 4.02, and the average score for a 4-star hotel is 3.88, we can ask, is there a difference? Is there a difference between these two things? Or could this just be because of randomness, right? So if if we had gone back to the website, and remember, we just picked 24 reviews from each hotel. And so if we revisited the website and we ran our script again that just randomly picked reviews, and we got like a different set of 24 reviews, we might get different scores here, right? And so the question is, if I ran this thing again, is it possible that the next time the 3-star hotels have an average score of 3.88 and the 4-star hotels have an average score of 4.02? Is that kind of difference possible? Like where we kind of get the flipped thing? And the ultimate question is there really a difference between the average score for a 3-star hotel versus the average score for a 4-star hotel? Or could it just because of randomness, right? So that's the kind of question. And I think I introduced this question last week on Friday. We looked at, what was it? What was the example I used last Friday? I don't remember. My brain is not working today. But it was the battery length, right? And we were looking at the battery length, battery runtime, and we said, could the difference we get be because of randomness, or is there something actually there? Okay, so how are we going to do this? Okay, I'm going to basically pull all of the values. So what I'm going to do is I'm going to run a filter, and I'm going to say, okay, for the hotel stars, we're going to just set it equal to 3. Okay, and then so you can always kind of just, this entire time part of the screen was cut off. I didn't even know. Okay, so you can always kind of verify some of your stuff, right? So one of the very useful features in RStudio is when you're viewing your data set, you can run filter, and you can enter values into here to kind of filter them. And so I say, I want to filter them to hotel stars as 3. And then down at the bottom, it says showing 1 through 19 of 168 entries. Okay, and so we have 168 entries there. And then back here, when I looked at my summary table, I said, let's group by hotel stars. And it also says count 168, right? So anytime you get kind of corroboration in your data, you feel like, okay, you can feel a little bit confident in your responses. And you can also do this in Excel. And again, I'm a big fan of Excel. It's just for a lot of these bigger analyses, we have to use code. Okay, so in Excel, and you guys all know that you get free Microsoft Office, right? As UCLA students. Okay, so if you don't know, just look up UCLA Office and you can get that. All right, so under you go to the Data tab, and then you click the Filter button. Okay, and then under the Filter button, under Hotel Stars, I'm going to just unselect the Select All. I don't know if you guys can see what I'm doing, but I'm going to just select the 3 only. Okay. And then it filters it down, and then it says 168 to 504 records. So again, all great news here. And then so if we look at this, we see the scores here are like 5, 3, 5, 4, 4, and whatnot. And basically what I want to do is, after I filtered out to Hotel Stars 3, we're going to pull out this column, the 5, 3, 5, 4, 4, those scores. So that's what I'm doing here. We're going to do Las Vegas hotels, filter down to hotel stars equal to 3, equals 3. We're going to select the score column. We're going to pull that, okay? And we're going to store the values that we've pulled into just this vector called 3-star scores. And then, so I can print out the 3-star scores, and we can see, okay, indeed we get 168 values, okay? So in the environment, you get this, it says numeric 1:168, meaning there are 168 values in there, 1 through 168, and then the values start off 5, 3, 5, 4, 4, 3, which match exactly what we see here. Okay, we're going to do the same thing, but this time we're going to do it for the 4-star hotels. Our 4-star scores, filter to hotel stars equal to 4. We'll select that thing and we'll pull that out. then we'll just go ahead and print that. So this is what we have for the 4-star hotels. And again, we can kind of change our filter for hotel stars to 4-star hotels. And we see these same values, 3, 4, 2, etc. And so that's what we're gonna do. Okay, and then to compare, all right, what is the difference between these two things? We can run t.test. We're gonna do t.test, 3-star scores and 4-star scores. Okay, 3-star scores and 4-star scores. So and again, what we're asking, so the X was the 3-star scores and the Y was the 4-star scores, okay? The mean of X was 4.02, the mean of Y was 3.88. And again, that matches, our table up here, 4.02, 3.88. And, our question is, if we revisited and ran this script again and downloaded different reviews, for each hotel, is it possible that we get kind of like the flipped version or something like that, right? We got, right now we have an average of 4.02 versus an average of 3.88, but is that difference really actually significant? And what is, can you read this output? Well, what does it tell us? What value are we going to focus in on? So we got two means, we're comparing them, and what kind of to compare these things, what should we be looking at for our test? So the resulting kind of value of significance is our p-value, and our p-value is 0.236. 0.236. What does that tell us? So we compare our p-value to the significance level. Okay, default significance level is 5%. All right. So the p-value from our test is 0.236. The p-value is larger or greater than our significance level. Okay, and so what that means, this indicates that we do not reject the null hypothesis. So if your p-value is greater than 0.05 or greater than your significance level, do not reject the null hypothesis. If your p-value is less than your significance value, you would reject the null hypothesis. What was the null hypothesis?
The rating score for 4-star, 3-star hotels are identical.
Yeah, that overall, so we're not talking about our sample. In our sample, they're different. In our sample, we have an average of 4.08 or 4.02 versus 3.88, okay? But we're just saying, in general, if we looked at all the 4-star hotels and all 3-star hotels, is there a difference in average rating, okay? Our null hypothesis says, you know what? I don't think there is. Okay, null hypothesis is in general the average kind of score of a 3-star hotel and 4-star hotel are the same. Okay, so kind of like no difference between mean scores. Okay. And then our alternative hypothesis is that the true difference in mean scores is not equal to 0, that there is some kind of difference between your average 3-star and average 4-star rating, okay? And so here we're not going to reject that, and we'd say our data as it currently stands this difference of 4.02 and 3.88 doesn't provide enough evidence to say that the average score of a 3-star hotel is different from the average score of a 4-star hotel. So that's what we have there. Okay. Let's look at the 5-star hotels. Okay. So if I look at the 5-star hotels, we can say, okay, well, the 5-star hotels have these. We got a lot more 5s at the 5-star hotels. Okay, and we can run a t-test here. And now, what do we get? We get a p-value of 7.37 times, it says 7.37 e negative 6, okay? So e minus 6 means times 10 to the negative 6. Okay, so basically like around like divided by 1,000,000. So, 7 in 1,000,000. So it's a very, very small number, right? So maybe I'll add this. So again, same kind of similar. Our null hypothesis here is the average score of a 4-star hotel and 5-star hotel are the same. And we compare our p-value to the significance level of 0.05. The p-value from our test is 0.12345 right? 737. Okay, so the p-value is much less than our significance level, and so we would reject the null hypothesis. Okay, and so our data now provides evidence to say that the average score of a 4-star hotel is different from the average score of a 5-star hotel, and and that difference is that the average score of a 4-star hotel is lower than the average score of a 5-star hotel. There is a significant difference between the mean ratings of 4 and 5-star hotels. Is that okay? You can also do the same thing between 3-star hotels and 5-star hotels. Similar conclusion. P-value is 0.00055. Okay. So we reject the null hypothesis. There is a significant difference between the mean ratings of 3-star and 5-star hotels. Do we feel okay about that? All right. Oh, I'm going to run out of time. I didn't get to what I wanted to do. But that's good. Okay, so that's a good place. T-tests, and I want to make sure you have seen this multiple times, because I have a feeling a lot of your data will be appropriate to use a t-test at some point in your data. I have a feeling. Okay. Now, there's a couple caveats. Is that if your data is not like representative of the population, like if the way the data was collected, you feel like, okay, I can't really generalize to the population, then this is, don't bother using a t-test. I mean, there's actually like, well, you got all kinds of problems there. but if you can't really generalize or something, then yeah, that could be a thing. The other kind of flip side is this issue of multiple comparisons. Here I only had 3 groups: 3-star, 4-star, and 5-star. Okay, but you can imagine some other kind of data set where maybe you have like 10 categories, okay? 10 categories of groups. So maybe you, or I don't know, like if you're gonna, maybe you want to compare averages from, across the country, and you've got 50 states now, right? And you want to compare our average of California and, Nevada, Oregon, Texas, all of these places. How many t-tests do you have to do, right? And if you have 50 states and you want to compare every single state with each other, that's like way too many comparisons, right? You got to do California versus Alabama, California versus Alaska, and versus Arizona. It's not gonna work. Okay, so in that case, we can do something called one-way ANOVA, and you know what? We're gonna have to hold off on one-way ANOVA till Wednesday. Okay, so on Wednesday we'll continue on with this. I will so I'll just write ... to be continued, and I'll upload kind of the updated version of this document to BruinLearn. And then we'll take a look at some of this on Wednesday, and then also hopefully, I guess we can continue working on this on Wednesday, but then probably by Friday, and then for 7th week as well, we'll start looking at some of the actual data sets from different student groups, and just kind of take a look and see what kind of issues will you encounter. There's probably some stuff where you have a column of text, and you want to, this is not a text mining class. Like, you can take an entire course where you learn how to like analyze text, but there's like some very basic tools. Like, does the text contain a certain word, right? And if you want to just say, hey, it contains this word, we can do some analysis there. So we'll take a look at that in the coming lectures. Let me go ahead and give you your last view quiz answer for today, which is the letter E. E as in elephant. E as in elephant. All right. Well, look forward to our group meetings this week. Good luck as you guys find your data, and we'll see you on Wednesday.